Okay guys, so let's get this started. You guys can move it a little closer if you want to, or you're good where you are. So in the early days of this project, before we even had a name, I was talking with one of my colleagues and trying to explain the idea behind the project. And I was struggling a little bit to really summarize it. And so I started finally talking about, believe it or not, the Ford GT and the general idea of a halo car. And so, a halo car is an automaker's crown jewel. It has all the best technology, the wildest design. Basically, a halo car is a car maker's touchdown dance, right? So my colleague said, well, why don't you call this project the Halo Project? Because that's what this is for our university. It gives our researchers who are solving all kinds of problems a platform to demonstrate their breakthroughs. Lets us pull together the best research from all across the university, put it in one nice package, and go out and show the world. And it's a little bit wild too, so we kind of like that. So without any more talking, let's have a look. The car is all electric. It has about 240 miles of range. It has 4 electric motors to power the wheels, which give it about 7,000 foot-pounds of torque, which is a lot. It also has 6 cameras, 3 LiDAR sensors, a supercomputer, and GPS. All of those things work together. Why do we need all that? Well, one of the reasons is we are designing this car to function, to actually drive itself off-road, even in environments where there are no roads or lines to guide the car. Today's self-driving cars primarily operate by following the rules. So they will, look at the lane markings and the traffic signs, but you put that car in the middle of a field, it's completely lost. So we're designing this car to operate even in the most unstructured of environments, using artificial intelligence and a lot of other advanced controls. And that's just one of the research areas that we're doing with this car. So a couple of things. I need to recognize some of the people that helped build this and get it here today. First of all, we have 6 headline partners for the project. One is, so they are NVIDIA, A123 Systems, Reinhardt Motion Systems, Yasa Motors, Hewlin Transmissions, and Clinton Body Shop, who John is here today, and they did the beautiful paint job and the finish on this car. John is also a member of the Society of Collision Repair Specialists, who is a booth that we're here today, so they were nice enough to bring us in, mainly because they're trying to put advanced technology in front of their constituents so that body shop specialists can see what the future looks like, see what a research university is working on as the future of cars, so their constituents can be prepared for that. And along those lines, on Friday, as part of their Ideas Collide series, I'll be giving a talk on autonomous vehicles and how the future of automotive design may be different as cars are starting to have more and more autonomous features on board. So, in closing, let me just say, this reveal is nice, but this is not the finish line for us. This car is a research tool our university will continue to use for a long time. So in a way, this is kind of the beginning for us. This is a car we're going to continue to improve. We'll take it out, we'll take it in all kinds of rugged terrain, collect data sets that we can use to build the artificial intelligence algorithms I mentioned. So that's it. You guys come in, talk to some of our students who work so hard on this project, and thanks for coming.
Before and kind of talk about the conversion, what you guys did or what the Clinton body did.
Yeah, so before this was a stock Subaru Forester.
Okay.
And our first step is we wanted to convert it into a off-road electric vehicle.
Sure.
So what we've done to that is with the electrification process, we added 3 battery packs, electric motors on each wheel.
Yeah.
And then we had the body modified. It has a 4-inch lift, and Clinton Body Shop's the one that did this paint and really helped us modify the body a lot. In the sense that we could fit these large tires underneath the car.
Sure.
That was not able to be done without any like modification.
Did you guys consult with Subaru at all on that? You know, like what you could do, you know, what was safe and not safe, just with what the kind of the structure of the car?
So no, we did not. We're not able to consult with Subaru. We have worked with them in the past, but for this project, this was solely internal research and what we've been able to do just on our own without.
So the powertrain conversion. I mean, because it's a traditional internal combustion engine. So what'd you do? You're the electrical engineer.
So ideally, like you said, skateboard chassis is about the best you can do. Unfortunately, with a unibody chassis like this, that's really hard to implement. So we did the best to keep our battery packs low. Like I said, there's 3 different battery packs. We've got one in the engine bay where we've replaced the engine. We've got one running down the transmission tunnel. We don't use a stock transmission anymore. And then we've got one in the back where the spare tire used to be. Yeah. And each of those weigh about probably about 400 to 500 pounds. That's the biggest thing. This car is a very heavy car, unfortunately. And you'll see the same thing with like Teslas too. All the batteries add mass, so it was really important for us to keep it as low as possible in order to keep the car safe.
What did you guys have to do in terms of battery encasement? In terms of modifying like the chassis or anything like that? I mean, was that did you work with Clinton Body on that? Is that something your own engineers did, or?
So it's something we did. Well, actually, I would say that Clinton Body Shop had a little bit of a part of it. So we just essentially cut holes in the chassis, and Clinton Body Shop helped us make it look a little bit better. A lot of the modifications we did in-house. We had to cut out the transmission tunnel in order to fit our packs. I can show you the packs later. It's designed so that we have 45 different battery, or 45 battery modules. And they're all arranged on these base plates, aluminum base plates. That the subframe attached to. And on top of it, we just have it's actually really neat. We've kind of got like a plexiglass kind of cover for it, so you can actually look inside the battery pack and show a lot of people what's actually going on in the battery pack. That's one thing I'm excited about is to bring people to the car and kind of, that's where that is, give them the whole tour of the battery pack.
That's cool. The aluminum for the subframe, was that as a mass thing, a lightweighting thing, or was that more of the durability, or?
So it is for lightweighting in that sense, but it's also for thermal conductivity. Sometimes I believe a lot of production battery packs, well, it goes either way. You can either liquid cool your battery packs or air cool them. Really, you don't need liquid cooling that much unless you're doing very high performance battery packs. So with this car, we kind of sit in the middle. So it's fully air cooled. But we actually are using a special thermally conductive paste. Really, it's a thermal gap filler that we're using to increase the conductivity between the modules and the aluminum base plate. And aluminum naturally just transfers more heat than steel. So that's actually, if you're able to look at the bottom of our base plates, it looks like a heat sink. We've actually cut little ridges in the bottom of the base plate to increase the surface area, and that gives us most of our cooling, or all of our cooling for our batteries.
Interesting. Did you find that was kind of like, in terms of, did you guys look at kind of cost effectiveness or anything like that? We're trying to get a sense of honestly what the automakers will be doing too in years to come to cool these things.
I don't think that we really looked into the cost effectiveness of it, but I think it makes sense for aluminum body cars that already have like aluminum chassis. So that seems to make a lot of sense to me.
Interesting. Did you guys do anything, to offset the battery in terms of modifying the rest of the vehicle weight or anything like that, or
So from the stock vehicle, when you add the batteries and our electric powertrain, even though we took out the engine and the transmission, this car is twice as heavy as it started out. So the suspension still needs a few tweaks because we've modified the weight distribution. So we're still figuring out how to get that. We just got the car put back together, so we're finding out how our weight distributions have changed. But definitely one thing that we had to do is we had to incorporate stiffer springs in order to support such a heavy weight.
Especially with the off-roading that you guys were trying to do with it.
Yeah, and we've actually got a 4-inch body lift on it just to aid in the suspension travel and ground clearance of the vehicle.
What talk about kind of the in terms of the with the car itself? What as you guys have been testing and all that? What kind of kind of maintenance calibration do you find? Like I know this is still in the experimental stage, but I mean, with the lidar, for example, or these things, one of the I know we were talking to the guys at May Mobility at one point, and they mentioned that one of the things that's been kind of just crucial is just really just having guys to come in and wipe the thing down every day, just because, or I don't know what. What have you guys found in terms of what service you need?
So really with all of our sensors, they are very finely calibrated.
Okay.
So thinking of each sensor by itself, say a LiDAR or a camera, each individual sensor has very small differences between them.
Okay.
So we go through a calibration process called Intrinsic Calibration that essentially calibrates each sensor individually. So each sensor has a different calibration in order to get it to look exactly like the other sensors in the car. And then on top of that, there's something called an extrinsic calibration, which we have with our LiDARs. You see we have 3 LiDARs. And the big deal with that is they have a specific calibration in order to all work together. So the data that LiDAR is transmitting, even though it's over to the side and pointed at some weird angle, it looks the same as that LiDAR, which is pointed straight up and down like a traditional car.
Oh, interesting. Okay.
So in terms of service, that complicates things because say like you have to replace a camera or replace a LiDAR, you've got to go ahead and do the intrinsic calibration. That's pretty straightforward. The manufacturers usually have ways, software and simplified ways that you can use to calibrate sensors. But the extrinsic calibration becomes a little bit more tricky because, like I said, these are specifically calibrated to work with each other. So the instant you move that sensor maybe like half an inch this way or tilted a little bit a different way, that just completely messes up your system. And I don't know what would happen, but it probably wouldn't be good.
Is it that when you said you've got all 3 kind of showing, or is it that you're kind of marrying the 3 LiDAR outputs so it's a wider field of view? Okay.
Exactly. So that's the way that we are able to take something that's like cocked off to the side really oddly, and we're able to transform it so its data looks like it's being seen from that perspective, which is straight up and down.
That's cool. When you're mentioning the intrinsic one, is that something where it just runs itself, or do you guys have to set up any kind of targets, or is that more like it'll just as you drive the car it'll figure itself out?
So I suppose intrinsic calibration could happen as you're driving with a car, but typically the way intrinsic calibration works is with cameras. You've probably seen those white and black checkerboard patterns. So with that one, basically, it's trying to figure out, basically each one, you see the checkerboard, is trying to figure out, okay, what is white, what is black? And then it's also trying to figure out how the lens of the camera distorts the image. Because the calibration knows that's supposed to be a square. Now you have to figure out the calibration parameters so that the camera feed makes it look like a square, because especially with this camera, this is a fisheye camera. See that on the entire car, it looks horribly distorted. So that calibration is definitely necessary in order to get that picture looking right.
But that's something you guys do manually, right? I mean, you have to set up the targets. It's not.
You definitely have to set up the targets pretty much.
It's not like a self-diagnostic or
Right.
How often do you guys find, I mean, like you were saying, you can't have this off by very, really, do you guys find, I mean, you're off-roading these things with the test, do you find them getting knocked around a lot, or is that something where once you've got them in place, they're pretty much in place?
Yeah, it depends on what we're doing. If we know we're doing a lot of testing, then we're going to be really careful to rigidly mount those and make sure that they move as little as possible. Because like I said, once they get knocked too out of whack, then they're not going to perform like they should. But yeah, during developmental stages, we spend a lot of time calibrating these things. So we're always tweaking things, changing things, taking apart the car. So yeah, calibration is a huge time sink for us.
Is that just every time when you're taking the car apart, you've got to put it back together and get everything back kind of the same? Really
Exactly.
The same issue?
So for calibration, like I said, the intrinsic calibration, the stuff like for each individual sensor, we've done that once and we don't have to address that again.
Okay.
But stuff like our stereo cameras and our LiDARs that all you have multiple sensors that work together.
Oh, yeah.
If those are the ones that you really have to recalibrate extrinsically after you change something.
That's fascinating, because that's right up. I mean, that's right up our reader's alley. I mean, that's their thing. You're trying to get it. Of course, with them, it's ideally they're not. They've restored it to the way it's supposed to look, but it's
Right.
the same issue.
Right. Really, the biggest thing is, you need to have kind of like a fine-tooth comb with a lot of these systems, and that kind of expertise is required to either service it or rebuild them in some cases.
Oh yeah. Have you guys found anything with the stereo cameras in there? One of the other ones that they've encountered is if the glass is aftermarket or things like that, or if there's a chip near where the camera is. Has that been a factor? I mean, you're off-roading. I'm thinking you're getting more gravel, things like that.
Actually, we haven't had a problem with chips or any kind of scratches.
Oh, nice.
Really, the only problem we've actually come around is at one point we didn't have a shroud around the cameras, and we're just seeing actually reflections in the glass. So that was really the only issue we came across.
That's cool. What kind of? It kind of talked a little bit more about your kind of the idea to pick the off-road, as a niche, and kind of what you're talking about briefly about kind of catering to parts of the world, or maybe just Mississippi, or just other states that are more rural. Talk about that choice a little bit more.
Yeah.
Sure, yeah. So I think it's important for CAVS as a center to kind of stay true to where we're at, and kind of be able to hit on research that will affect people in our state as well. So an off-road autonomous vehicle will do a lot better in Mississippi than one, say, that's, like Uber's, that's for a city grid, that we don't really have that. So that's one thing that's kind of just important to kind of return to, I guess, our people that support us. Sure.
Do you see it as more of, is it like like for unpaved roads exactly, or is it more of an enthusiast, or not an enthusiast, or more recreation, like, okay, I'm on a safari in my autonomous vehicle, or I guess what kind of use cases are you guys visualizing for these things?
I think one of the funnest use cases that really we came up with at the beginning of designing this car is kind of like the enthusiast side of things. So imagine that you are skier or one of those fancy rollerbladers that go up big hills and rollerblade down or ski down the mountain.
Oh.
So imagine a scenario where you can drive your car to the top of the mountain, do your thing, whether it's skiing or skateboarding or whatever. Then you can actually have your car meet you at the bottom of the mountain,
I can
so that
totally
you can
see
go
that.
back up.
Yeah. Yeah, you're right. You're right. That totally makes sense. Or hiking, or even just boating, or so.
And of course, from an engineering standpoint, I think of like some of the complicated trails out there. I can't think of any by name right now, but just from an engineering standpoint, that's a really cool accomplishment for me. I'm actually pretty competitive. I want to see this guy conquer different trails that even people have difficulty on. So that's, for me, I'm just nerding out on it. That's my
cool.
that's my kind of game with this car.
Do you run into issues with the? Have you guys kind of hit like a grade that you can? I know, I forget who it was, but somebody just did. I think Pikes Peak or something, and it was either an electric or autonomous or both, or where did you guys have a certain incline you find it can do or not do, or?
Yeah, that's actually ties into a little bit of the things that I was talking about you earlier. Like I said, a lot of on-road autonomous vehicles kind of ignore the ground.
Sure.
So whenever you have some huge grade like that, guess what? Their sensors are starting to see the ground, and that doesn't look too great.
Oh.
That looks like something straight in front of me. They don't understand.
They just see it as like a horizontal plane. Oh yeah.
Yeah,
okay.
exactly. They think it's a huge obstacle a lot of the time, or they can.
Yeah.
So yeah, that's a lot of our work is designed to sense more information about the ground and the terrain. And of course, one of the things we, when we're using path planning to determine what's the best path, We're trying to choose path that minimizes changes in elevation, and try to like choose the smoothest one. But yeah, that's one of the things we're dealing with is using a lot of information about the ground and figuring out what kind of scenarios. Because I know our path planning algorithm, it works okay for maybe flat ground and gentle inclines, but we've actually got to switch to different algorithms whenever we encounter something ridiculously large.
Oh, interesting.
So yeah, it's and honestly, we actually use the path planning algorithm, and then we once we realize that we're having issues with the path planning algorithm and it's giving us scenarios that the car cannot manage, we switch to a simpler algorithm that's like, okay, go to this point and then turn the path planning algorithm back on.
Oh, really? Yeah. Oh, you can. I didn't realize it was conditional like that.
Oh yeah, very much so. I mean, we're using different conditional algorithms based on the terrain ahead of us and also the speed of the car. Like there's a lot more with vehicle dynamics wise, there's a lot more things that are changed as you're increasing speed.
Oh, so what have you guys found for, kind of top speed, things like, I mean, you guys, what have you, how much have you opened it up out there?
So top speed, we really would limit it for any kind of like autonomous driving.
Okay.
Honestly, it's pretty scary to think about going maybe 30 miles an hour. Honestly, 10 miles an hour seems really fast whenever you're not holding the wheel. So yeah, we actually haven't been able to do much electric driving with it, so we haven't been able to take it up to top speed yet.
Oh, really?
Yeah, so
wait,
we can do it.
Well, how'd you drive it then? Or, I mean...
Oh yeah, we can switch between modes. So yeah, we can switch between modes, so it can be human driven and it also can be an autonomous vehicle. But yeah, we still haven't gotten to the point where we're comfortable using it at high speeds.
Oh yeah. Oh no, I'm sorry. I thought you meant like you just switched to electric only. I'm like, oh, do you put the engine back in or okay?
Oh yeah, no, it's human mode and autonomous.
The other one that's always been kind of coming up in the use cases. I'm assuming when you guys test it out, you have like a human, in there as like a backup driver, or do you? Does that?
Yeah,
rural,
for sure.
Or you're out somewhere rural, so it doesn't matter. Or?
Yeah, our policy is that we always have to have a human at the wheel.
Okay.
This car, we would get in trouble if we were able to unleash it. And honestly, in Mississippi, I don't know what the autonomous driving laws are, so I'm not even sure if it's legal for us to have a autonomous car on the road.
What are you guys finding in terms of when when it disengages or it alerts you? Because that's been one of the issues with just, the more kind of the mainstream interactions. I would assume there'd be that with the, if you're trying to use it as a recreational thing, like the lead time to, monitor the road. I mean, do you find yourself like, kind of getting bored? Do you find it when it alerts you? Is it tough to kind of get into it? I know there's some like behavioralists that are trying to study that kind of stuff.
So are you asking like when you switch from like a autonomous mode to like a human mode, what that transition's like?
Yeah, I mean, the car alerts you to take over, or you get, you feel like you need to take over. I kind of two things. One is like, what's it like? I mean, do you get just bored to tears, or are you just kind of trying to monitor the road while this thing's in autonomous mode? And then I guess talk about when it disengages and tells you to take over for it, or however you guys work that.
Right. So at the moment, it's definitely an abrupt change where it disengages and it's gone. So as a production vehicle, it's not quite there yet.
Sure.
Yeah. And I can't say that I've ever had a dull moment in the car. Usually when you're testing it, I've got a buddy in the passenger seat, and there I'm asking, okay, what's our temperatures here? What's our battery voltage here? And what's the car gonna do with these kind of controls? So I'm probably not the best person. I've never dozed off and goes off in this thing.
No, that's a good point.
Yeah.
What are you guys monitoring besides the fact that it's driving well or not well? I mean, you mentioned you're actually monitoring a lot of the internal vehicle, like your battery and all that, or?
Yeah, so we actually have a human and human technology interaction group over at CAVS.
Oh, you do? Okay.
Yeah. So one of the interesting things is we're trying to develop software. If you look on the interior of the car, we've actually got it set up so there's places for several tablets, and the idea is we want kind of like to figure out what's a good user interface for, say, a driver that's interested in like the autonomous side of things. So like we can have one tablet that will be show camera feeds from all over the car. I mean, even more that would give the user more information than they would normally see with a like mirrors or something.
Oh, I've heard that, where it's a confidence building thing or something like that.
Right. So we've designed one interface for like users, but we've also considering another user interface for people like me, the developers, because I'm as on the electrical side of things, I'm very interested in the temperatures of the motors, the battery voltage, how much current we're putting out, those kind of things. And even like control states, whatever state our controls are in. So honestly, I feel a lot better when I can look down and I kind of have an idea what the car is going to do next based on what state it's in at the moment.
Oh, interesting.
So,
is that stuff you guys have pre-programmed, or is that like Subaru's driving modes or something like that?
Oh no, yeah, this is stuff that we've designed in-house. Basically, we've taken all of our components and they're putting out all kinds of information on the CAN bus, and we're actually, with this car, normally it's just someone with a laptop and I'm asking, what's going on right now, and it takes them like half a minute to figure out to find that CAN message. So yeah, we finally realized that, hey, we need to work more on user interface.
Interesting.
So that's what we've been working on right now, is having 3 tablets in the car, being able to, okay, this one will be a user tablet, and I need this one in developer mode to give me more information, that kind of thing.
Do you find, when you're driving this, you mentioned the battery, kind of the battery state, does it, because of what you're trying to do with this thing and the train and the weight, what kind of charge do you get? And also just, do you find just the power demand, is the power demand of the actual AI or all this stuff itself really an issue, or is it more just the standard moving a heavy object at this speed,
So we can tweak, those are all parameters that we tweak, and we actually, our algorithms aren't perfect, so there is a little bit of human tweaking that has to go on between, say, like you're doing on-road driving and then off-road driving. You need a little bit more, you got to be a little bit more aggressive with the electric power steering and a little bit more aggressive with the throttle in some occasions. But yeah, it's all digital controlled, so eventually our computers we can iron things out, and it's really not that big of a problem.
What kind of battery life do you guys get?
So we've actually wanted to compete with commercial vehicles like Tesla.
Yeah.
So in this car, we were able to put a 90 kilowatt hour battery pack in it, and that is significant because that's, I think, Tesla's largest battery pack is maybe about 100 kilowatt hour.
Yeah, and you have to pay for that.
Yeah, so we're able to get an estimated 240 miles out of it.
Oh wow.
Haven't done that yet. But that's definitely some testing that we plan on doing in the future.
How tough was the conversion of that? Because that seems like an interesting point. If you want to, let's say gas goes up to like $20 a gallon or whatever, and you want to convert your old, again, your Subaru Forester or whatever, to electric. Was that difficult? What was that? How many labor hours did that take to?
So, like I said earlier, this is a unibody chassis, and it's absolutely horrible to work on in that sense. You can't just strap a skateboard chassis onto it. So it requires a lot of modification to the floor of the car.
Okay.
And that's really in the case of the transmission pack and the rear pack. Those floors had to be completely modified. On the bright side, once you take the engine out, you've got a pretty big space up at the front. So if you want maybe like 30 kilowatts of power, energy, then you're pretty good there. We didn't have to modify much to put a battery pack in the engine bay. So modifying the interior of the car is a bit of a challenge. Like I said earlier, we have a battery pack that runs down the transmission. So a lot of the car, we actually had to cut out a lot of the transmission tunnel running down the car. So you can see we got an aftermarket center console set up. It's set up with these little charging stations for the tablets I was talking about earlier.
Oh, yeah.
So we've got 2 in the front, 1 in the back. Tablets aren't there right now, but they support wireless charging, and it's kind of like a design that, you have these tablets always in the car, and you pick one up and figure out, what do I need to know? Put it on the tablet.
That's cool.
On the other side of things, the gear shifter's gone. So we just got a pretty little button interface, several buttons that light up. So of course there's no manual transmission, so you just press a button and you're in drive.
Oh.
And of course one button off to the side is autonomous button. So when you're ready to go into autonomous mode, put your foot on the brake, press that button, and then whoosh, you're gone.
That's what those are your transmission or your, and then okay, the one over there. Yeah.
Yep. They're not lit up right now,
No.
but park, reverse, and neutral drive. So things like neutral don't really make sense in an electric car. But it makes a lot of sense to people who drive an electric car. So we just kind of like, you still have a neutral.
That's funny.
Yeah.
I like the emergency stop button too.
Yeah, the emergency stop is definitely useful. Basically what it does is it'll disconnect all high voltage, it'll return control to the user. And we've actually got some interesting safety systems that we've developed in here.
Oh yeah.
One of my, I guess, prized accomplishments was actually making a circuit board that wires into the power steering system.
Oh.
And it's actually designed to detect whenever someone grabs onto the steering wheel. It's designed to detect if someone's trying to take control of the steering wheel, and then it'll relinquish control to the user. So
that's pretty cool. So does that work with any inputs? Like, okay, hey, I hit the brake, so the car knows. Okay, the user wants it.
Most definitely. That was an easier one because there's already like switches that relay brake and pedal information on the CAN bus, but we kind of had to figure out a way to do steering. And then there was also the question of, does the gas pedal count? So that's one of the things we had to consider. It's like, okay, how do you switch into autonomous mode? How many like inputs are required? So I believe the way that we do it is you need like three different inputs in order to switch into that mode. So you gotta have your foot on your brake, you gotta press the button, and you gotta hold it there, and then you have to release it. So things like that.
That makes sense. So it's not like an accidental, like,
Yeah.
That's
Yeah. So we've considered safety throughout this process.
Do you guys have does the car alert you at all when it needs you to take over and encounters something, or is it not, since you guys are monitoring everything anyway, that's not really an issue? You guys just take over when you want to?
Usually that's the case.
Okay.
And like I said, we haven't worked out, we don't have that seamless transition, sorry. We don't have a transmission either. We don't have that seamless transition between the car acting on its own to the driver. It's kind of really abrupt, and you gotta be there to take the reins whenever it gives it to you.
That's cool.
So I'm definitely more of a practical kind of guy, but Matt, he gets how to show things, and the LEDs were his idea. Yeah, this is one of our 3 battery packs. One of the really interesting things about this car is, I think, showing it's really fun because it's got the clear case. So I can show everyone that, these are the inverters that drive the motor. This is how the battery pack applies voltage to the rest of the car. The only thing you really don't see down here are the battery modules that go below this shelf. So like I said, there's 45 different modules, 15 in the front, 15 in the middle, 15 in the back.
Okay. Was it tough to kind of wire? I mean, I guess that's sort of your role anyway, to wire it into all the existing vehicle systems, or?
Yeah, kind of. Not really.
Yeah.
We've got the only real interface we have between the stock vehicle and our system is the CAN bus. So we're taking in a lot of digital information, and we're actually putting out a lot of digital information in order to make all of its systems happen. So there's a few other circuits, but really we built this car, it's really interesting. We're actually able to take out all of these battery packs, all of the powertrain. We're actually able to lower it off altogether onto the single frame. And there's actually just one little connector I can unplug to completely separate this from the car.
Oh, really?
Yep.
Oh, wow. That's cool.
Yep. So that's, I guess, a testament to how much CAN communication is used in vehicles nowadays.
Speaking of that, is cybersecurity really an issue, or is it enclosed? Is it closed enough where it's not like you can't really access it outside of your interfaces, their physical ones?
Right. So cybersecurity has really increased over the last few years. This is a 2014 Forester.
Okay.
So that was really when cybersecurity was ramped up, but that was before it's got to the level today. So the biggest impact of cybersecurity for us is it makes it a lot harder for us to work with cars.
Yeah.
Because everything's locked down. It's like the CAN message is all encrypted and all that kind of jazz. But really for us, like I said, it's getting harder and harder to work on it. But with us, we're considering it because we're actually using network communication, like having a Wi-Fi network in the car.
Okay.
That opens up a lot of, I guess, opportunity for hackers, having a wireless network attached to your car. So yeah, that's an aspect. We haven't really, I don't think we're doing anything like cutting edge with cybersecurity, but it's something that we do consider. The back of the car, I can show you the battery pack in the back, but some of the back of the car is not finished. So
That's okay.
okay.
So I mean, we know it's a work in progress. Is this for the battery? Is this?
Yeah. So this is actually a third battery pack, the rear battery pack. So I don't think I'm gonna give y'all a very good view of it because I can't open the trunk.
That's fine. Do you run into ground clearance problems with this though? I mean, this is getting back into, you've raised it, but now you just got this thing on there.
Yeah, so ground clearance is an issue, and it does limit some of the terrain we can go on. But it was really a trade-off. We wanted, it was really a trade-off for the extended range. What's really important for this car is we kind of wanted it to make it look relevant compared to other vehicles like the Tesla that can do 200, 300 mile range.
Yeah.
So that was a little bit of a trade-off. We're a little limited in what types of terrain we can go over because of the ground clearance, but
I can see the range. The good idea is to have it in rural areas.
I will say on the topic of range, we're actually using some new technology in our battery modules.
Yeah.
We're using A123s, lithium-ion batteries that are now that are a nickel, manganese, cobalt chemistry. And what that is, it offers 50% more energy storage. So yeah, that really helps us get to the level that Tesla's at. Because Tesla's getting that huge range because they can put skateboard chassis in their car. They design it from the ground up. So to compete with them, we really had to up our battery game and use some of those batteries from A123.
That who you guys designing for you?
Yes. This is actually, the batteries in this car is actually in their first production run of nickel manganese cobalt batteries.
Oh, really?
Yep. Nickel manganese cobalt batteries are very similar to the traditional LFPs.
Okay.
They are higher voltage, so that's one of the challenges that we've had to address is this car runs, I believe, at 375 nominal volts, and it can reach max volt at a full charge. It'll be 430 volts, which is actually a lot higher than a lot of the high voltage equipment that you normally see in production cars now. So we've had that's made it hard to find components for our car just because we're running at a higher voltage than normal because of these nickel manganese cobalt batteries.
What do you mean components that can handle that charge?
That's the thing. It's like a lot of production cars operate around 320.
Oh, okay.
So we're up here at 375. It gets a little iffy. Certain things work, certain things don't want to work with that voltage.
You guys, how do you charge it with the standard, like kind of the standard?
Actually, no. We've got
You know what I mean, like the standard electric vehicle ports or whatever those. Or did you guys design something?
We're actually using a standard J772, but it's also the combo charger.
Oh,
Are
okay.
you familiar with DC fast charging?
Yeah, a little bit. So that's kind of what I was curious about.
Yeah.
Okay, so you have the standard, the kind of the.
It's the standard, and then it has the